say that it can be transpose or determinant of a square matrix. Determinant of a square matrix. Determinant of a square matrix. So under that we can say this, the determinant of a square matrix. Determinant of a square matrix. Determinant of a square matrix is the determinant having the same elements as those of the matrix. Determinant of a square matrix is determinant having the same elements as those of the matrix. For example, if we have matrix A equals to, if we have matrix A equals to, we have 5, 2, 1, 0, 6, 3, 8, 4, 7, 8, 4, 7. This is a matrix. Then we can easily find the determinant of this matrix. Sometimes we write as det A. Determinant of A will be equal to, as we have said, we have 5 into 6, 3, 4, 7, then minus 2 into, we have 0, 3, 8, 7, then of course we have plus 1 into 0, 6, 0, 6, then 8, 4, like that. So when we open up, you have 7 times 6, we have 42. 42 minus 4 times 3, so we have 42 minus 12. What we have? 42 minus 12, 30 times 5, yeah, 150. Then we have 7 times 0, we have 0. Then minus 8 times 3, we have 0 minus 24, we have negative 24, times negative 2 plus 48, plus 48. Then we have 0 times 4 times 0, we have 0, then minus 48 times 1, so we have minus 48. So at the end of the day, we have 150 as the determinant of matrix A. We have 150 as the determinant of matrix A. Now, what happens when we transpose this matrix and calculate the determinant? So A transpose will be equal to what? We said that when we are transposing a matrix, we are simply interchanging rows and columns. So the transpose of A here we shall have 5, 2, 1, 0, 6, 3, and then 8, 4, 7, like that. So this will be the transpose of matrix A. Now, let's again find the determinant of this transpose. So we have determinant of A transpose will be equal to, of course, we have 5 into 6, 4, 3, 7, then minus 0 into 2, 4, 1, 7, then plus 8 into 2, 6, 1, 3, like that. Like that. So we have 7 times 6, that is 42. 42 minus 12. 30 times 5, 150. Of course, this will be 0. That will be 0. Then plus 0. Then we have 3 times 2. 3 times 2. We have 6. 6. 6 minus 6. 0 times 8. 0. So it's equals to 150. So you can see that the determinant of the matrix is equal to the determinant of the transposed matrix, because this is 150, and after transposing matrix A, you will still get the determinant as 150. So you can say that the determinant of a sphere matrix, the determinant of a sphere matrix has the same value. The determinant of a sphere matrix has the same value as the determinant of the transposed matrix. It has the same value as the determinant of the transposed matrix. The same value as the transposed matrix. Now, we also need to know this very important, that a matrix whose determinant is 0 is called a singular matrix. A matrix whose determinant is 0 is called a singular matrix. It's called a singular matrix. It's called a singular matrix. It's called a singular matrix. So I want us to move on. We discuss what we are calling cofactors. Cofactors. So we can say this. Cofactors is simply the minus of the elements. Cofactors is simply the minus. Is simply the minus of the elements in the determinant together with each place sign. Together with its place signs. I'll repeat. Cofactors is simply the minus of the elements in the determinant together with its place sign. For example, if we have matrix A equals to, if we have matrix A equals to 2, 3, 5, those are the elements. 4, 1, 6, 4, 1, 6, 4, 1, 6, and 1, 4, 0. This one is matrix A equals to that. Okay, so remember we say that these are the elements of the matrix. That the elements of the matrix. Now we have element 2, the minor of element 2. Then the minor of element 2. This is element 2. So the minor of element 2 will be what? The minor of element 2 will be 1, 6, 4, 0. 1, 6, 4, 0. So that is the minor of element 2. So which equals to what? which equals to, you now take 0 times 1, which is 0, minus 4 times 6. So it's like you have 0 minus what? You have 0 minus 24, which equals negative 24. But what is the place sign? Place sign of element what? Of element 2. Place sign is positive. So it will be now plus minus 24. Plus and minus, it will be minus 24. Like that. That's how to get the cofactor for element 2. Let's get the cofactor for element what? Element 1. So you start by getting the minor for element 1. So the minor for element 1 will block that column and block that row so that we have 2, 5, 1, 0. Like that. So this equals to, let us start with the place sign. Let us start with the place sign for 1. So we have positive, negative, positive. Remember the alternate. Remember I said if you want to get the place sign, we start with this value. This is positive. So from positive, negative, positive. Positive, negative, positive. Positive, negative, positive, they will alternate like that. So the starting point is there. So this would what? Positive. So the place sign is positive. You can start with the sign like that. Therefore, you have 0 times 2, you have 0 minus 5 times 1. So we have 0 minus, we have 0 minus 5. But remember, you have the place sign which is positive, so it's like we have plus minus 5, which is minus 5. So that is it. Then let's find the cofactor for 3. Cofactor for element 3. So the minor for element 3, we block that column and this row so that we have 4, 6, 1, 0 equals to, let us start with the place sign. Place sign for 3 is to be negative. We start with the sign, the place sign. So 0 times 4, 0 minus 1 times 6, 6. So we have minus 6, which equals to 6, which equals to 6. Let's also find the cofactor for element what? Element 4. So the minor for element 4, block this column, we block this row and this column. So we have 3, 5, and then 4, 0. So this is the minor for element what? Element 4. So what would be the place sign for element 4? Positive, negative. So it will be minus into 3 times 0, we have 0, minus 4 times 5, we have 20. So we have minus 20, which equals to 20. So that is how we find the cofactors of the given one, of the given element. The given elements. So what we are saying, to get the cofactors, the place sign of the minus is very important. We start with the place sign, the minus of the element in the determinant together with their place sign. The place sign. Any question? Any question? Okay, adjoint of a square matrix. Adjoint of a square matrix. Adjoint of a square matrix. Now, if we have matrix A equals to, if we have matrix A equals to 2, 3, 5, 2, 3, 5, 4, 1, 6, 4, 1, 6, that's matrix A. Now, from this matrix A, we can form a new matrix of cofactors. We form a new matrix of cofactors. Form a new matrix of cofactors. We form a new matrix of cofactors from matrix A. Now we can say let that matrix be what? Let the matrix be C equals to, now this is the matrix for cofactors, A11, A12, A13, A21, A22, A23, A31, A32, A33. So we are saying this is a matrix of cofactors from matrix A. From matrix A. So we want now to get these values. The value for element A, A11, A12 like that. So we shall have A11 will be equal to, so what is the minor for 2? The minor for 2 is 1640, okay? So we have 1640 like that. This equals 2. What is the place sign for 2? Is positive, isn't it? So you write positive like that, and then we open the bracket. So it will be 0 times 1 minus 4 times 6 minus 4 times 6. So it's like 0 minus 24. So this equals to plus minus 24, which equals to 24. So we have A11. Then we move on to A12. This equals to A12 is this one, is 3. What is the minor for 3? The minor for 3 is 4, 6, 4, 6, 1, 0. The place sign for 3 minus, so equals to minus. Then we open the bracket. 0 times 4 we have 0 minus 1 times 6, which is 6. So this equals to minus 6, which equals to 6, which equals to 6. We move on to A13. A13 is 5. So the minor for 5 will be 4, 1, 4, 1, 1, 4, like that. The place sign for 5 is positive. So equals to plus, open the bracket, 4 times 4 is 16, minus 1 times 1, minus 1. So this equals to plus 15, which equals to 15. So we are through the first row. We move on to the second row, which is A21. A21, we are on 4. Okay. So what is the minor for element 4? 3540. 3540. The place sign negative equals to minus. 0 times 3 we have 0, minus 4 times 5 is 20. So we have minus 20, which equals to positive 20. That is A21. We move on to A22. A22. What are the minor for this? A22 is 1. So we plug this and that. So we have 2510. 2510. The place sign positive, negative, positive. So it will be plus. 0 times 3 have 0, minus 1 times 5, 5. So this equals to plus minus 5, which equals to minus 5. We are through with the A22. Then we move on to A23. A23 is 6. What are the minor for 6? 2314. 2314. The place sign positive, negative, positive, negative. So it's negative, so it is minus. Open the bracket. So 4 times 2 we have 8. We have 8 minus 1 times 3 we have 3. So we have minus 8 minus 3, it will be 5 plus 5. So minus plus 5 minus 5. We are through with the second row. We move on to the third row. A31. A31 is number 1 here. So what are the minors for element 1 here? 3516. 3516. The place sign positive, negative, positive. That is positive. So we have 6 times 3, which is 18. 18 minus 1 times 5, which is 5. So this equals to plus 13, which equals to 13. Move on to A32. A32 is element 4. Element 4, we shall plug that column and plug that, so we have 2546. 2546. The place sign negative equals to minus 6 times 2 is 12, minus 4 times 5, 20. This is equals to minus 8 minus minus 8, which equals to positive 8. Lastly, we have A33, the last element, which is 0. The minus for 0 is 2341. 2341. The place sign, positive, negative, positive, negative, positive. So it's positive into 1 times 2, it will be 2, minus 4 times 3, it is 12. So which equals to minus 10, which equals to minus 10. So therefore we can now rewrite the matrix for cofactors now that we have A11, A12 like that. So we can now rewrite the cofactors. Let me rub this. So the matrix for cofactors, which is C, would be equal to A11, you can read for me, negative 24, A12, 6, A13, 15, then A21, 20, A22, negative 5, A23, negative 5 again, then A31, 13, then A32, 8, A33, negative 10. So you can see how to get a matrix of cofactors. Very simple. Matrix of cofactors. So this is a matrix of cofactors. Then I want us to transpose this. So C, we transpose this, it will be equal to what? Negative 24, 6, 15, then 20, negative 5, 13, 8, negative 10. So when we transpose matrix C, then that is what we have. So this is what we are calling the adjoint of the original matrix A. This is now the adjoint of the original matrix A, written as written as in short, written as that adjoint of matrix A. Adjoint of matrix A. So in brief, we are saying to find adjoint of matrix A. To find a matrix of adjoint A, number one, we form the matrix of cofactors. Form the matrix of cofactors. We form a matrix of cofactors. That is step one. Then step two, transpose transpose the matrix of factors to get and adjoint A. Get the adjoint of the matrix. There are simply two procedures there. Form the cofactors, then you transpose. Then you will have coordinate the adjoint of the given matrix. Anybody with a question here? Okay, so far we have discussed how to get the determinant of a square matrix. Now we know how to get the adjoint of a square matrix. Now I want us to move on and discuss how we can be able to get the inverse of a square matrix. The inverse of a square matrix. Inverse of a square matrix. So we have this to say the adjoint of a square matrix. The adjoint of a square matrix is important. The adjoint of a square matrix is important since it enables us to form the inverse of the matrix. The adjoint of a square matrix is important since it enables us to find the inverse of the matrix. Full stop. If each element of the adjoint of the adjoint of a matrix is divided by the value of the determinant of the same matrix, each element of the adjoint of a matrix is divided by the value of the determinant of the same matrix, the resulting matrix is called the inverse. The resulting matrix is called the inverse of the matrix. The resulting matrix is called the inverse of the matrix. I.e., if the matrix is A, then the inverse will be denoted by A like that. The inverse of, if the matrix is A, then the inverse will be A raised to that is noted by. Now, let's have an example. Let's have an example. We have matrix A, which is given by 2, 3, 5, 2, 3, 5, 4, 1, 6, and 1, 4, 0. That is matrix A. Now, let's find the determinant of this matrix. Det A, determinant of this matrix will be equal to, you have 2 into 1, 6 minus 3 into 4, 6, 1, 0 3, 4, 6, 1, 0. Then plus 5, 4, 1, 1, 4. Then we open up. We expand the determinant. We have 0 times 1, we have 0, minus 24. So we have negative 24 times 2, negative 40, negative 48. 0 times 4, we have 0, minus 1 times 6, so minus 6, so we have negative 6 times negative 3, we have plus 18. Then 4 times 4 is 16, 16 minus 1 times 1, we have 15. 15 times 5, 75, right? 75. So when you add negative 48 plus 18 plus 25, what do you have? Yeah? So 45. So 45. So that is the determinant. Now, remember this is the equation we have already considered. So after we have gotten the determinant, then we need the cofactors of this. So we have already calculated. What was the cofactors, which is C, equals to cofactors negative 24, 6, 15, then negative 5, then so this is the cofactors. We have already considered them. Then we now transpose to get the adjoint, okay? So we can say adjoint A equals to transpose the matrix, which will be now negative 24, 6, 15, 20, negative 5, negative 5, 13, 8, negative 10. So this is the adjoint of A. But what have we said? We have said that for us to get the inverse, we divide each element of the adjoint by the determinant. That's what we have said. So this is the adjoint. Therefore, the inverse of matrix A, the inverse of matrix A given by that will be equal to inverse of matrix A will be equal to our determinant was 45, so it will be 1 over 45 times 1 over 45 times the adjoint of the matrix, which is negative 24, 20, 13, 6, negative 5, 8, 15, negative 5, negative 10. So that would be the inverse. That would be the inverse of matrix what? Matrix A. The inverse of matrix A. Okay, we can summarize by saying this. To form the inverse of a square matrix A, to form the inverse of a square matrix A, form the inverse of a square matrix A. Number one. Evaluate the determinant of A. Evaluate the determinant of matrix A. Evaluate the determinant of matrix A. Number B, form a matrix C of cofactors. Form a matrix C of cofactors. Form a matrix C of cofactors. Number 3, get the transpose of matrix C. Transpose matrix C. Transpose matrix C to obtain the adjoint of A. To obtain the adjoint of matrix A. Transpose matrix C to obtain the adjoint of A. Divide each element of number 4. Divide each element of adjoint A. Divide each element of adjoint A by let A. Divide each element of adjoint A by determinant. Number 5. The resulting matrix is the inverse of original matrix A. The resulting matrix is the inverse of the original matrix A. That is how we can navigate through solving this kind of equation. We start by getting the determinant, form the matrix of cofactors, transpose the cofactors to get the adjoint of the matrix, then divide each element by 1 over the determinant. We divide each element of the adjoint by 1 over the determinant to get the inverse of a given matrix.